Hi, and welcome to this tutorial on algebra. And for the past few tutorials, we've focused on the topic of finding the vertex of parabolas and quadratic functions. And I thought today I would give you a couple of formulas, a couple of pretty handy formulas to quickly find the vertex of a parabola without having to actually complete the square or to use symmetrical properties. It's a formula which is pretty simply you take your A, B, and C values and you plug it into these formulas and you will get the coordinates of the vertex almost instantly. So let's get started, and I'll show you how we actually arrive at these formulas. So by now we probably know that there's actually two common forms of quadratic functions or parabolas, and those are first the standard form, which is generally written as y is equal to ax squared plus bx plus c, and the other form is y is equal to ax minus h squared plus k, and h, k are the coordinates of the vertex. And usually the questions that you get in a lot of cases is, given a parabola in standard form, in this form here, you are asked to find the vertex of that parabola. And usually what it boils down to is transforming this equation of the parabola in standard form into vertex form. And then once you've converted it into vertex form, you're able to then read off the coordinates of your vertex by just getting your h and k values directly by looking at your equation of your parabola in vertex form. But we're not going to do that this time around. What I'm going to do is to derive a couple of formulas that will actually allow you to take your A values, your B value, and your C value, given that you've been given the equation of the parabola in standard form, and to use those values to actually find out your h and k. And so let's get started and let's try that. So what I'm actually going to do in the first step is I'm going to take this general form of a parabola in vertex form. I'm just going to expand it, and maybe I'll use a different color just to make it show up a little bit differently. So let's expand our equation, our general equation in vertex form, and so what we're going to get is y is equal to ax, and actually what we're going to do is we're going to expand x minus h squared. So how do you expand x minus h all squared? Well, you take the first term, x squared, you multiply the first term and the last term, and multiply that all by 2, so 2xh, and you square the last term. And that's what you get when you expand x minus h squared, and then you add on your k. I'm going to scroll down here. Now let's keep going. We get y is equal to ax squared. I'm going to bring this a in and multiply it by all of these terms in the brackets. So we've got ax squared minus 2ahx plus ah squared plus k. And so let's collect up all the terms. We've got y is equal to ax squared, and then we've got minus 2ahx plus ah squared plus k. And what I'm going to do here is I'm going to use a little bit of a different color. So that's our constant term at the end. This is our coefficient in front of our x. This is our coefficient in front of our x squared. And what we're going to do is we're going to compare that with the equation in standard form. I'm just going to rewrite that here. Ax squared plus bx plus c. And really what we're going to do here is, you'll notice that we've still got our a coefficient in front of the x squared. We've got our b here, and we've got our c here. And what I want you to see is that by expanding our quadratic equation, our equation of our parabola in vertex form, what I'm going to do here is I'm going to compare the coefficients of both these equations. They essentially are equivalent, but by expanding the equation of our parabola in vertex form, we've expanded it out. We've gotten all these terms, and what I'm going to do now is by looking at these items here, which I've boxed in, we've got an x term here in this form and an x term here in this first equation. And what I'm going to do is set them equal to each other. So we've got negative 2ah is equal to b, and in this case here we've got c is equal to ah squared plus k. And so let's go ahead and solve for our h value, because ultimately what we want to find are the coordinates of our vertex, h and k. And we want to find a formula for h and k in terms of a, b, and c, because if we're given the equation of our parabola in standard form, we know what our a, b, and c are going to be. And so if we can find a formula for h and k in terms of a, b, and c, then we should very quickly be able to find the vertex of our parabola just by using the values of a, b, and c. So let's go ahead and solve for h from this equation here. H is just going to be negative b over 2a. So that's our first formula for finding the x coordinate of our vertex. And in this particular case here, we want to solve for k. And so let's isolate k. K is going to be c minus a h squared. And I'm going to scroll down here a little bit. And we now know what h is. We now know what h is in terms of b and a. So we're going to substitute negative b over 2a in for h over here. So let's go ahead and do that. So k is going to be c minus a times negative b over 2a all squared. And let's simplify that. K is going to be c minus a times b squared over 4a squared. And let's continue to simplify that. We're going to get c minus b squared a over 4a squared. And we've got an a on the top and the bottom on this term here, so we're going to take that a out. So we've gotten b squared over 4a. And if we get a common denominator of 4a, we can rewrite that as 4ac minus b squared all over 4a. And that's going to be our k. So there we have it. We've gotten our formula for h, which is negative b over 2a, and our formula for k, which is 4ac minus b squared over 4a. And in our next tutorial, we will find the vertex of our parabola by using these two formulas. And hopefully that'll make it a little more clear on how we go about doing that. Thank you, and we'll see you next time.